with college algebra on this channel, and also have quite a few on my other channel, my Dr. T Math and More. So I'll put a link in the description. So if you don't find what you want in this channel, you can go ahead and go to that channel. And I appreciate you watching and subscribing to the channel. So let's continue with the first one. The first couple that I'm going to look at are what we call linear equations. So these are equations where the variable, and again, these are all equations to start off with, all in one variable. Whatever the variable is, it could be x, y, z, but it's just one variable. And we're looking at first degree. Okay, so normally if there's a variable that appears, the exponent will be an x. Now it is possible that there could be an x squared, for example. Let's say I have x. Let's say I have an x is equal to x squared plus 2. And let's say over here I put another x squared. Well, you really only have an x because these cancel out. So this is really a first degree. Okay, so first degree equations or linear equations are equations where the highest exponent or the largest exponent of a variable is a 1. Okay, so this is first degree. Also, I want to remind you that anytime you're solving one of these types of equations and you get something like say 0 is equal to 0, that's basically telling you that you have an infinite solution. Infinite solution. Okay. Very basic example would be if I give you x equals to x. Normally when you solve a linear equation, the objective is to get the variable on one side of the equation and all the values on the other side. And of course you wind up with x equal to the answer or the number, right? So see this when x is equal to x, it should be clear that whatever I plug into the left side, I have to plug into the right side, so I'm going to get the same number. So this one would have an infinite solution. So if I try to isolate the x's, I bring this x to this side, I get 0 is equal to 0. On the other hand, if I get something like 0, say, is equal to, let's say a number 2, that's a contradiction. 0 cannot equal to 2. So you get something like that. That's basically telling you that you have no solution. Okay, kind of like if I give you x is equal to x plus 5. I say, okay, solve for x. What you want to do is you want to, again, get the x's on one side. So you say, okay, let's cancel this one, add a negative x here, add a negative x here. And you can see these cancel, go to 0, this goes to 0. I get 0 is equal to 5. Okay, that's telling me that this has no solution. Okay, so keep that in mind as we go through these equations on this video, and later on we get into more complicated equations. Okay, so on the first one we have 3x minus 8 is equal to this expression on the right side. Okay, so it's first degree. So the objective then is to always try to simplify each side of the equation. So 3x minus 8, there's nothing I can do with that. But on the right side I have parentheses, and then I have a number in front of the sum of these, so I can multiply using my distributive property. So here I can multiply by 2. Okay, so 2 times x will give me 2x. 2 times a minus 5 is a minus 10. Okay, this one I have a minus and then a 3x plus 2. That means you actually multiplying by a negative 1 if you want. That subtraction applies for every term in the parentheses there. So this will give me minus 3x. And then a minus 2. And then the rest stays the same, plus x. minus 5. And then we want to collect terms. Okay, so obviously on the right side, that's going to stay the way it is. So this will be 3x. I'm sorry, the left side, that's going to stay the way it is, 3x minus 8. And on the right side, I combine my terms. So what do we have? Let's look at the x's. So right here I have 2x, a minus 3x, and an x. Okay, so 2x minus 3x is minus x, and then there's an x. That cancels to 0. So that goes to 0. Okay. And then, now let's look at the numbers. Minus 10, a minus 2, that's negative 12, and a minus 5, that's a negative 17. Okay. So again, the objective when you're solving a linear equation, that is first degree equation, is you want to get your x's on one side and all the numbers on the other side. Doesn't matter which side, whether left or right, as long as they're isolated. So here I'm going to get rid of this minus 8 by adding an 8 here. And adding an 8 to this side. Whatever you do to one side, you have to do to the other side. Otherwise, you don't keep the equation balanced, and it's going to be an incorrect procedure. So now, the minus 8 and the 8 cancels. I get 3x. Minus 17 and 8 is a minus 9. I divide through by 3 to isolate the variable. These divide out. This actually becomes a 1x, which is the same thing as x. So I just write down x. And then negative 3 divided by positive 3 is a negative 3. So the solution to this one is x is equal to negative 3. Okay. So if we did make a mistake, that should be the correct answer. But you can always go back and check your answer by plugging into the left side. And for the variable, put in negative 3. Any place you have an x, put in negative 3 and combine. And you should get the same value on both sides of the equation. Otherwise, there was a mistake here. But in this case, we're correct. Okay, so let's cancel this. And again, remind you that if I go to faster some of these, just go ahead and just stop the video and rewind. Clear this. Go to the next one. Okay, the next one is again a linear equation, because you see x is there, but they all have first degree, exponent of 1. The difference in this one and the first one is this one has fractions. So generally speaking, whenever you have an equation that has fractions, to simplify it or make it easier to solve the equation, multiply through by the LCD, or the lowest common denominators of the denominators that appear. Get rid of the fractions, and then you proceed like we did in the first one. So in this case, we have a 2, a 3, and a 6. The lowest common denominator, in this case, would be a 6. 2, 3, and 6, all divided into 6. So what I'm going to do is I'm going to multiply through the equation by 6. So every term of both sides gets multiplied by 6. Okay, so 6 times this x minus 3 over 2. Notice that 2 will go into the 6 3 times, and then you multiply by 3. Okay, so that would give me 3x, and then the 3 minus times the minus 3 is a minus 9. Okay, I'm multiplying the first term here by 6. 2 into 6 goes 3, and then 3 times the x minus 3, I get this. For the next term, minus x over 3, again, same thing. 3 goes into 6, in this case 2, and I multiply that by 2, and I get minus x times 2 is minus 2x. I get this. Okay, then I proceed to the right side. Every term gets multiplied by 6. And of course 6 goes into 6, so 6 times 1 divided by 6, the 6's cancel out here. This will just give me a 1. And then 6 times 2x, the denominator in this case is 1, right? So it's 6 times 2x is 12x. And then 6 times a negative 3, okay? Denominator again of the minus 3 is a 1, so it says minus 18. Okay, so let's combine. First, the left side, 3x minus 2x will leave me with an x. And I still have the minus 9. And over here I have 12x. And then the 1 in the minus 18 gives me a minus 17. Okay, so now that's as far as we can go as far as a simplification goes on each side, but now we try to isolate the x's. So I'm going to add a negative 12x here to cancel this term and do the same thing on the other side. So x and a minus 12x is a minus 11x. Okay, and I get a minus 9. These cancel out, 12x and a minus 12x cancel out. I'm left with a minus 17. Okay. So now here, I want to get rid of the minus 9. I have an x over here on this side, no x on the right side. So just add 9 here, positive 9, add a 9 here. So that'll give me then the minus 9 and the 9 will cancel on the left side. So that'll give me minus 11x equals 2. And then minus 7 and a 9, minus 17 and a positive 9 is a minus 8, negative 8. And then here we divide through by negative 11. These cancel out, becoming 1, so I get 1x or x. So x is going to equal to negative 8 over negative 11. The negatives cancel. I get x is equal to 8 over 11. And this should be your solution. Okay, let's clear this. Okay, so that gives you an idea how to solve linear equations. Now the next one moves up to quadratics. Solve each of the following quadratic equations. Okay, unlike the linear equations, quadratics are second degree equations. Remember, these are all in one variable right now. So if you have a second degree equation or a quadratic, you can expect to have either two solutions, one solution, or no real solution. Okay, so you can have two real solutions, you can have one real solution, you can have no real solution, or in some cases we could have what are called non-real or complex solutions. So this is the form of the quadratic right here. Ax squared plus bx plus c is equal to 0, where a is not 0, okay? Because if a turns out to be 0, then this term is gone. And all you have is bx plus c is equal to 0, and that's a linear equation, okay? So we don't need a formula for that. You solve it just like I did the first two, okay? but we're assuming that A is not 0. Okay, so the procedure or procedures for solving quadratic equations, basically you have either factoring, you have the method of completing the square, or you have the quadratic formula. Okay, most of the time you're going to use factoring or the quadratic formula. Now I do want to point out to you that there are some equations that are very difficult to solve by any method, and using a graphing calculator will facilitate that. And I do have a lot of videos using graphing calculators to solve equations in algebra. I also have some for solving trigonometric equations on this channel and also on my other channel, which as I mentioned before, there'll be a link to that in the description. But we proceed this way, okay? What you're going to do is you're going to assume that the equation factors. So normally, if you're going to solve a quadratic equation, you want to put it in this form right here, okay? So in other words, you want one side to be 0. So I have x squared minus x minus 30. Okay, adding negative 30 to both sides puts it in this form. Okay, so here's the way it works. Okay, one side is 0, so then you proceed to factor this, okay, if it factors. So again, it's a trinomial, so use your method for factoring trinomial. So in this case, I have factors of x squared are x, and the factors of 30, we could have 2, we could have a 15, we could have a 6 and a 5. So let's see, we want to come up with this format here. So in this case, looks like a minus 6 and a plus 5 will work. Okay, you can see x times x is x squared, minus 6 times 5 is negative 30, and if I multiply the middle terms here, minus 6x, 5 times x is 5x, minus 6x, and a 5x is minus 6. So this checks out. Okay, so that way I have it factored out. So anytime you have the product of two numbers or two factors equal to 0, either one factor is equal to 0 or the other factor is equal to 0, or they could both be 0, right? Because 0 times anything is going to be 0. 0 times 0 is 0. So what they tell you to do is take if you have one side equal to 0 and you have it factored out, and you simply set each factor equal to 0. X minus 6 is equal to 0, can be 0, or x plus 5 can be 0. So you solve each of these equations now. So we actually get two linear equations. Add 6 to both sides and I get 6. So x can be 6. Add negative 5 to both sides, or x can be negative 5. So I get my solutions of 6 and negative 5. Now I could still use this formula. I could still use this formula right here to solve this, even though this one factors. I want to point out to you that the first thing you want to do is see if you can factor it. If you can't factor it, then you want to use this formula. I wouldn't really bother with the method of completing the square. I won't go through that here, but these two methods will work fine. If they don't, then the only way you could do it would be, say, a graphing calculator. Okay. Now, I do want to point out to you, if you use the formula, this expression right here under the radical, this b squared minus 4ac, that's referred to as your discriminant. Okay, that's the discriminant. This basically dictates the type of solutions that you have or will get. So in other words, if this b squared minus 4ac turns out to be 0, then all you're going to have is minus b plus or minus 0 over whatever 2a turns out to be. So basically, this is going to be the case where you have one real solution. Okay, and again, we're assuming that the a, the b, and the c are real numbers here. Okay. Now, if it turns out that b squared minus 4ac is positive, if this expression here turns out to be positive, then you're going to have two real solutions. Okay, two real solutions. Now, what type of real solutions are they going to be? You could have rational, or you can have irrational. Basically, we think of the irrational ones, the ones that have radicals. For example, 2 plus or minus the square root of, say, 3. That would be, say, considered a irrational solution. If it's rational, then, in other words, if this expression right here is a perfect square, you're going to have no radical, then you have numbers like 6 and -5. Those are considered rational solutions. Anything with a fraction also will be considered rational, as long as it doesn't have the radical. Now, if the b squared minus 4ac turns out to be a negative number, then you're going to have what I call complex or non-real solutions. So you could have something like 2 plus or minus I, okay, something like that. Or you could have something like 2 plus or minus, and then you could have a radical on top of that. That would still be considered complex or non-real. Okay. Now, just to show you that this can also be solved using this formula. Let's clear this. So I would have x is equal to, so it's minus b, but in this case b is -1, so it's negative times a -1, plus or minus the square root of b squared, but that's, b is -1, so it'd be -1 squared, minus 4 times a is 1, that's the coefficient of the x squared term, and c is -30. And that's over 2 times a, which is 1. Okay, so what do we have then? We have -1, that's 1, plus or minus the square root of, and then here it's going to be -30 times 1 times a -4, that's a positive 120, and then -1 squared is 1, so 120 and 1 is 121. That's over 2. Okay. And then the square root of 121 is 11. Okay, so x then is going to equal to 1 plus 11 is 12 divided by 2, that's 6. 1 minus 11 is -10 divided by 2 is -5. Okay, so we get the same thing that we got using the factoring method. But notice we did spend less time solving it by factoring. Okay, so if you can avoid the quadratic formula, go ahead and do it by factoring. If it doesn't factor, then you have to go pretty much this route. Go to the next one. So again, this one is quadratic, and this is one that doesn't factor out. If you try to factor this out, so it's already set up for you. One side is 0, so the only option I have here is to put a 2x right here and an x here. And because the third term is negative, one of these signs has to be positive, the other one has to be negative. So I have plus and a minus, or a minus and a plus. And the only combinations of 5 that I could use here is a 5 and a 1, or a 1 and a 5. But there's no way I'm going to get a -8 for the middle term, so this is not going to work. Okay, factoring won't work. So I use the quadratic formula. So x is equal to. So notice in this one here, a is going to be 1. That's the coefficient of the square term. B is going to be -8. That's the coefficient of the x. And then the constant is c, which in this case turns out to be a -5. Okay. So then I just plug those values into the formula. Okay. So b is -8, and this is minus b. Okay. So this would give me an 8. Okay. B is -8, and then a negative makes it a positive. Okay, so it'd be plus or minus. And then under the radical, it's the square root of. Okay, so b squared, okay, b is -8, so -8 squared, that's -8 times -8, so this will be a 64. So this first term here is going to be 64. Okay, minus 4, that's part of the formula, times a is 2, and then c is -5. And that's over 2 times a is 2. Okay, so what do we have here? We have a 64, and then here we're going to have -5 times 2, that's -10 times -4 is a plus 40. So this will be 104. So this will give me 8 plus or minus the square root of 104 over 2 times 2, that's 4. And 104 is not a perfect square, and it's not negative, so I know I'm not going to have a non-real solution. But because I don't have a perfect square, I know I'm going to have a rational or irrational solution. That is, the answer is going to contain radicals. So then you have to look at the 104 and try to find the largest square that divides it. Try a 2, try a 4, and notice if I divide 104 by 4, I get 26. 4 times 26 is 104, so I simplify this and say, okay, this is going to give me 8 plus or minus, and then the square root of 4, that comes outside the radical, that's a 2, and I'm left with 26 under there. 26 doesn't have any perfect squares, that's as far as I can break that down, and then this is over 4. And you always want to simplify. So notice the 8 and the 2 have a common factor of 2, so I can factor out a 2 here, and this will be 4 plus or minus the square root of 26. Then I can divide this 2 into the 4 here. So x, then I come over here, is going to equal 2. Okay, reduced by 2 here, so cancel the 2 there. So this will leave me with 4 plus or minus the square root of 26. And then 2 into 4 is 2. Okay, and that would be your answer. Okay, and usually I would leave this one in this form. That's simplified. Okay, now if you want to go ahead and divide this out, normally they'll leave the answer this way, but if you want to divide this out, remember you have to divide it into both of these. So if you want to divide it out, you go 2 into 4, that would be 2, and then this into this won't go, so you just leave it as the square root of 26 over 2. Don't try to divide this 2 into the 26, because that 26 is under radical. So you can write your answer this way or this way. Normally, you'll find that they'll leave it this way. Now, should they want a decimal approximation, then you can use your calculator and compute the square root of 26 and add it to 4 and subtract it from 4 and then divide by 2 and you get an approximation. Okay. So again, if I'm going too fast, please pause the video and check it out again. Let me clear this. Let's look at the next one. Okay, this one I've got x squared minus x is equal to negative 3. So again, I want to write this. I want to write this in the standard form. So this will be x squared minus x. And then I bring this 3 over, add 3 to both sides to make this a plus 3. And then this side will be 0. Okay. And then again, I try to factor this. X squared minus x plus 3, try to factor it. So again, if I was going to factor it, I would put 2 factors here. And the only factors of x squared are x and x, so that would be here. Because the third term is positive and the middle term is negative, then both signs here would have to be negative. The only factors of 3 that I could have here are 1 and 3, or 3 and 1, and that's not going to give me this negative x in the middle term, okay? So that's not going to work, okay? So I got to use the quadratic formula. So you can see here, a is going to be 1, that's the coefficient of the squared term. B is going to be negative 1, that's the coefficient of the x, and C is going to be 3. Okay, so using the formula then, it's a negative b. Okay, so it is right there, negative b, but b is negative 1, so a negative negative, that makes us a positive 1, plus or minus the square root of, okay, and then we look under the radical, it's b squared, and b is negative 1, so negative 1 squared is 1, minus 4, that's part of the formula, okay, times a is 1, times c is 3. Over 2 times a is 1, so it's 2 times 1. Okay, so we go ahead and simplify this. We get 1 plus or minus the square root of, so here we got 3 times 1 times a negative 4, that's a negative 12. 3 times 1 times negative 4 is negative 12, and a plus 1 equals a minus 11 over 2 times 1 is 2. Now anytime you have the square root of negative, that's where you get the imaginary or the complex number. Okay, so this square root of negative 11 can be written as the square root of negative 1 times the square root of 11. But the square root of negative 1, that's what is called the imaginary unit. That's going to be I. So this comes out to that. So we can write this then as the answer then would be 1 plus or minus the square root of 11 over 2. And then you have the imaginary unit. So avoid putting the I over here, because sometimes if you put it over here, you make this radical sign too large. You're going to put it underneath the radical. It doesn't go underneath the radical. So just to make sure it's clear, we'll put it in front. So this is a problem, an equation that has imaginary or complex solutions. Okay. So like I said, this will be a series of videos dealing with solutions of equations, pretty much every type of equation that you can encounter in college algebra. And if you want to see more details, look at the channel, see if you can find other things you want. You have any suggestions, go ahead and post them. And again, remember the link to my other channel will be in the description. So I hope these were helpful, and we'll see you in the next video.